Hi everyone, Miss Pak again from Mirror Lake. If you missed yesterday, don't worry. We learned yesterday in a nonfiction text, while we practice reading Animal Tongues, that we don't have to read every single page in order like a normal fiction book. Today we can jump around and you'll still get the gist or understanding of what the text was mostly about. You can also help us do the main idea as well today after we finish reading. So again, remember, we like to ground ourselves in a special target or a focus for the day. So today it's going to be, I will determine if a word has short I sound, I, long I sound, I, or if the I says the E sound. Whoa, it can make those three different sounds. Here's an example of a long I sound. Remember, long I says its name. So the word hike, I hear the word I hear the sound I. How about the middle one? Short I, it says I. Let's try that. Picnic. Do you hear that I sound? And then the last one, I sometimes makes the E sound, like in the word piano. It's still an I when you spell it, but when you say it, it says the piano. So let's take a look at those three different vowel sounds. So we're looking for words with I in it, and then deciding should it go in the long I sound where it says I, short I sound, remember what that makes? I, and then the I says E. So let's look for that when we're reading today. This is the same book as yesterday, but don't worry, if you did join, we'll read different sections of this book. This is called Animal Tongues by Don Cusick. Notice that this book, has photographs and pictures instead of illustrations or drawings, which gives me a hint that this is a non-fiction book. Like we said yesterday, I know it's nonfiction because it also has a table of contents, which oftentimes you might see, hey, it tells me the page number, but this tells me all the different types of tongues I will be reading about in this text. Before we actually jump into our reading, I want to also take a look at the back. There's something called a glossary, which tells me different vocabulary words and the definitions of it, of what it could be. This also, I notice, hey, it tells me, it's giving me kind of captions of the pictures here. It says left close-up of hook-shaped papilli on a house cat's tongue. We read about that yesterday, the little hooks. And then on the right side, this is a close-up of taste buds on a cow's tongue. Wow, yikes. Then there's also something called the index, which is another tool, another text feature most nonfiction books have. And you can look for, hey, if I want to find and just read about giraffe tongues, which I think we're reading about today, you can go to page 12 or 13. So that's how you can use it. Nonfiction texts are set up usually in a different way than a chapter book or a fiction book. And hey, look at that. This is giraffe tongues. Giraffes use their long, almost 2 feet long tongues to pull the tops of tall tree branches down to their mouths so they can eat the leaves. Their tongues are so strong that giraffes can pull down heavy branches and chew thorns without hurting themselves. Scientists describe the giraffe's tongue as prehensile, which means it has adapted for holding and grasping. People are often amazed when they see a giraffe's tongue up close because it's black. What? Since giraffes need to eat leaves all day to get enough food, their tongues are exposed to a lot of sun. Scientists believe the black tongue color keeps it from getting sunburned. Whoa, who knew? And how many of you have ever been burned in the sun before? I know I have. That's pretty cool that their tongue is prevented from getting a sunburn. Test it out. I always want to read a little text feature they have down here. They give us some cool extra facts. Pretend you're trying to clean some cake frosting off the side of your mouth with your tongue. Try that with me. Like, oh, it's stuck up there. Can you feel your tongue stretching? I can. Now imagine you have cake frosting stuck in your ear. What? Okay, can you stretch your tongue that far? Let's try. Oh, mine can barely reach out of my mouth. Giraffes use their tongues to clean bugs out of their ears. Wonder if they'd like some cake frosting. That's pretty crazy that their tongue can reach their ear. I hope you tried that too, but don't hurt your mouth. Our bodies were not made for that. Keeping us focused back on here with determining if a word has short I, the I sound, long I, or if the I says E. There's a bunch of words in here that have the letter I inside. Let's take a look at some examples. How about the word scientists? That I right there, I hear the scientist. Do you hear the I? That would go under long I. Awesome. How about the word it? It. Do you hear I? No. Do you hear E? No. Or do you hear I? Hey, I hear the word it, or the sound I. So that would go under short I. There's a bunch more, but I'm going to move on. Remember that I can read this out of order if I want to. So I'm going to switch. Oh, and it's a brand new section. Here's my heading on. Guess what we're going to learn about? That's right, snake tongues. People who don't like snakes really don't like snake tongues. My mom's very afraid of snakes. When they see the snake's tongue flicking in and out, they often get scared or grossed out. The snake isn't trying to scare them, though it's just trying to smell them. So it's not trying to scare you, it's just trying to sniff you and see who you are. When a snake flicks its tongue in and out, the tip of the snake's tongue collects scent molecules from the air and brings them back to the Jacobson organ on the roof of its mouth. The Jacobson's organ tells the snake if there's a tasty snack, a big fat rat maybe, nearby. The V shape, also called a fork in the snake's tongue, helps tell the snake which direction a smell is coming from. Male snakes also use their tongues to smell the air for females. And then remember, we read that down here, is snakes don't have to open their mouths to stick out their tongue. Instead, the tongue goes through a hole on the top of the mouth. So let's look for the eyes. I'm seeing a bunch of words when you're going back. So it is tricky. You're trying to comprehend and understand all the facts you're reading, and then also keeping track of your goal here. But that's nice that you have it written down. And again, always keeping your journal or a pencil nearby is helpful too. Like the word, for example, flicking. I hear the I sound. Blue tongue skink tongues. I've never even heard of this. Blue tongue skinks are one of the 6 different types of Australian lizards that have blue tongues. They use their tongues to smell their surroundings in the same way snakes do. They also use their tongues to scare away predators such as eagles, snakes, and large lizards that are trying to eat them. When a predator comes too close, the blue-tongued skink first tries to make it go away by hissing and making its body look big. If that doesn't work, the skink sticks out its long blue tongue. Some scientists think the sudden appearance of a bright blue tongue surprises predators, giving the skink a chance to run away to safety. Other scientists think the bright blue tongue works like a warning color, telling predators that the skink is poisonous and might bite. I'm hearing a lot of the long I sound. Test it out. Suck on a blue popsicle until your tongue is bright blue. Then go stick your tongue out at your mom and see if she's afraid or surprised. Lots of I's in there. And our last one here. Nectar Bat Tongues. A nectar bat from South America takes the prize for longest tongue. It's 1.5 times longer than its body. Whoa. Scientists believe the bat has such a long tongue because it feeds on the nectar of a very long flower. The bat's tongue is a hollow tube, like a soda straw, so that it can suck the nectar from inside the flower. Where does the bat keep its long tongue when it's not eating? In its rib cage, of course. What? The nectar bat shown here is from southeastern Arizona, and its favorite food is a sweet nectar in flowering cactus. I'm going to read that last part. Testing it out. To see how long the nectar bat's tongue is, stand against a wall and have a friend measure your height. Multiply the measurement by 1.5. Cut a piece of yarn or string to its length, then hold it against one side of your mouth and imagine how you would fit a tongue this long into your mouth. That's a fun. Try it at home. Remember, when we're looking for the main idea, it is what the text is mostly about. We're going to take a look at one section of animal tongues today. So remember the clues to refresh your memory. Main idea is something we do after reading nonfiction text. Here's some clues to help us. Read this with me. Number 1, what is the text mostly about? Good. Number 2, look at the title and headings to help us. We're going to be reading more about or doing our main idea, Nectar Bat Tongues, that we read. So, hey, that's a huge clue on what this was mostly about. Number 3, look at the pictures. For this text, what pictures do you mostly see? If you said nectar bats and their tongues and maybe the plant that they eat from, you're right. That gives us clues to point us to the main idea. Number 4, sometimes the main idea is stated in the first or last sentence. We said only sometimes that works. So let's take a look real quick. A nectar bat from South America takes a prize for the longest tongue. Okay, it's about tongue still. And then looking at the very last sentence, the nectar bat, hey, same nectar bat, that's like actually, let's read number 5 real quick. Look for clue words that are used repeatedly. That's a clue. It keeps saying nectar bat. Shown here is from southeastern Arizona, and its favorite food is a sweet nectar in flowering cactus. So there are some clues there, and I'm noticing a pattern that it keeps talking about nectar bats. So remember, we're going to look for the main idea, what the text is mostly about, instead of doing a SWIBS, somebody in wanted but so, like we did with our fiction texts. So if you take a look with me on here, can you go ahead and read the learning target with me? This is our focus for this little section. Go ahead. I will determine the main idea and key, remember key means important, details of the section Nectar Bat Tongues. Determine just is a fancy word for we're going to find the main idea. So we're going to do that together. Again, I have some sentence stems here. The main idea of Nectar Bat Tongues is blank. Here's some thinking ideas for us. What was the text mostly about? And remember, we can use, the clues that we had from the previous picture that I showed you. Then moving on to one key detail from the text is, remember that your details and evidence always need to come from the text. And then here's a little hint in the red. Always look back in the text to find your evidence. You don't want to copy the text word for word. You should restate what you read in your own words. And then moving on to another key detail from the text is blank. Do you think it's a good idea for us to write the same detail twice? I hope you said no, because that's kind of boring. And remember, in the picture here, sorry, let me show you that again. If it was like this and it had one leg on the table, would that be a sturdy table? I don't think it would be. I want lots of details right there, so lots of legs to that table. That would be helpful. And make sure and tell me that I have the correct main idea. So again, Always look back in the text to find your evidence. You don't want to copy the text. You should restate what you read in your own words. So we just took a look at that text here, and we also looked at the clues here. We found the title, we looked at the headings, we looked at the pictures, the first and last words, and clue words that were used repeatedly. So we're going to take a look at this section and do the main idea. This is to check our comprehension to make sure we understand what we're reading. Right now, I want to remind you that I'm not cheating by looking back in the text. That's what good readers do. They go back in the text, and sometimes they reread it. Good readers reread it all the time to make sure they have the correct information. Remember, this time, our learning target or focus was thinking in my head, what is this mostly about? So something you can do is also go back and reread if you have to, and that's a great idea. I'm going to go switch to here. So now we have the sentence frames. The main idea of the Nectar Bat Tongues is blank. One key detail from the text is blank. Another key detail from the text is blank. If you want to challenge yourself, you could come up with 3 or even 4 details if you wanted, though this short text might not have that many details. If you want to do it based on a whole book, you should, or a lot of the books will actually have multiple details. So let's go down here and see what Miss Pock did. Remember that mine is not the only correct answer. If yours was similar and you have the key details, a bunch of key details, then you know that you're on the right track. There is not just one way to write this and only one answer. Make that a little bigger for you so you can see. Can you read that with me? Ready, go. The main idea of Nectar Bat Tongues, see how we restated what we were reading about, is that we learned special facts about their tongues. Is that something you thought about for the main idea? Or if you didn't, do you agree with my main idea? One key detail from the text is that their tongues are 1.5 or 1.5 times longer than its own body. What a cool fact. Another key detail, I'm still using the sentence stems, which are great, from the text is that their tongues are like a straw, which helps them get the nectar inside the flower. Now, I know for my 3rd graders, they would have to add another detail after each one, or kind of explaining on their own, which is something you can totally go and do on your own if you're older and you feel like you're capable of that. But for right now, this is great. We have the main idea written, and we have 2 details that support the main idea. We want to make sure that the details are not just in the text, which they are, but that they support the main idea. The Nectar Bat Tongues being 1.5 times longer than its own body. Is that a special fact about the Nectar Bat Tongues? I hope you said yes, because that totally was. And then let's look at the last detail, that their tongues are like a straw, which help them get nectar inside the flower. Is that another special fact about their tongues? It sure is. Awesome job, guys. Thanks for doing that main idea with me.
Hey everybody, welcome back. Nice to see you again. This is Mrs. Nelson back with another math lesson for some 3rd grade math practice this summer. I wanted to just quickly remind you what we talked about in our last lesson this week on Monday. So we are exploring properties of multiplication this week, which are just like rules in math that can help us remember and solve different multiplication equations and facts. So yesterday, we talked about the commutative property. And that is just the rule that says that we can switch our factors around. So I could have 2 times 4, or I could have my equation 4 times 2. And no matter what order our factors are in, our product will always stay the same. So in this example, if we know 2 times 4 equals 8, then we know 4 times 2 is equal to 8. And my two arrays show that. So yesterday we talked about the commutative property, where we can switch the order of the numbers we're multiplying, and our answer, our product, our total will always stay the same. Today's rule that we're learning about and exploring is called the associative property of multiplication. And this rule is special because it applies to when we are multiplying 3 factors or 3 numbers. So in an example like at the top here, if we were solving 3 times 4 times 8, the associative property is a rule that says that we can solve those equations by multiplying the factors and grouping them in any way we want to. And our final answer, our product, should still always be the same. So it's kind of a similar rule to the commutative property because it has to do with changing the order of factors doesn't change the total or the answer you end up with. But associative property is different because we're working with 3 factors, multiplying 3 numbers. So it says, when you are multiplying 3 factors, you can multiply any 2 of the numbers first, then multiply that product by the last factor, and you should always get the same answer. And I have a little example on the back here showing what we're going to do and practice today. So I have the equation 4 times 2 times 5. And I'm showing 2 different ways I could group the factors. So up here, I could solve 4 times 2 first. And I get 8 when I multiply 4 by 2. 4 groups of 2 is 8. And then the last step is to multiply by the factor that's left, which is 5. So 8 times 5, and that equals 40. If I count by 5s, which is what this little bubble here shows, if you were to count by 5s 8 times, you would get 4 to 40, or skip counting by 5s. And then underneath, same 3 factors, only on this example, we're grouping 2 and 5 together and multiplying 2 times 5 first. And then our last step would be to take that product, which 2 rows of 5 would be 10, and multiply 4 times 10 to figure out what 4 tens would be equal to. Just another strategy we practiced a couple weeks ago. You could use repeated addition, adding your tens together, and we would still, because of associative property, end up with the same answer of 40. So that's what we're exploring today, is how we can multiply 3 factors, grouping them in any way we want, multiplying 2 of them first, multiplying that by the last factor, and no matter which order we do it in, we should always get the same answer. So I want to show a visual example of how associative property works, and I'm going to do it with this equation as our example equation and some toothpicks. So this equation here says 2 times 2 times 3. Those are the factors we are thinking about. And when we do associative property, we are grouping 2 factors together to multiply those 2 numbers first. And we show that using a symbol called parentheses, which are kind of like these curvy lines, and they sort of go around the factors that we're grouping. So now I have written those 2 parentheses around 2 times 2, which means we're going to think about two groups of two first. So with my toothpicks here, I can model or show what two groups of two would look like. And we can see that if we have two groups of two toothpicks, we would have 4 toothpicks altogether. Now that I've done that step and figured out that 2 times 2 is equal to 4, my last step is going to be to figure out if I had 3 of those 4s, if I multiplied that by 3, how many would I have altogether? So I'm going to take those two groups of 2 and I'm going to put 2 more of those groups here. So you can see that here's my 2 times 2 part of my equation, my 2 groups of 2. And now I've multiplied that by 3 to show 3 times 2 times 2. So that would be 4 plus another 4. So we would altogether have an answer of 12. So let's look at that same equation again. 2 times 2 times 3, and this time we have the parentheses around 2 times 3. We're going to group those factors together first and solve that part first. So 2 groups of 3, if I wanted to show that with my toothpicks, would look like this. There's one group of 3, and there's another group of 3. So there's 2 times 3. And now my last step is to multiply by 2. So I'm going to show 2 of those groups. Here's my 2 times 3, my 6 toothpicks. And here's another 2 times 3, another 6. So again, we still have a total of 3, 6, 9, 12 altogether. This time we just decided to multiply 2 times 3 first. The total stayed the same. Today is to be able to use the associative property to multiply, and specifically to use it as a strategy to multiply 3 factors in an equation. We can use any of the multiplication strategies I've taught you so far. So repeated addition, drawing arrays or equal groups, skip counting, that help you solve. We will multiply the 3 factors in 2 different ways. So we'll be grouping them together, kind of like I showed with the toothpicks, and solving that same equation 2 different ways to prove that it doesn't matter which 2 factors we multiply first, we will always get the same answer. We should always get the same answer. When you take a look at the whiteboard before we go to these 2 examples that we just looked at with our toothpicks, I have some words here. I took some of our words off the word wall just to make room for the whiteboard. So I left the most important words for today on here, remembering what multiplication means, the product, the answer that we're finding in a multiplication equation, the factors, those numbers that we're multiplying by each other. And then today, of course, the name of our rule that we're exploring is the associative property. And parentheses are what we call these curvy lines that go around part of the equation that we're doing first. So parentheses, we also see parentheses in reading and writing, and they are used differently in those subject areas. But in math, when we see parentheses, they mean that we should be doing that step first in an equation. Visual examples, pictures in math, really helpful. So before we move on from this equation that we used as an example and looked at how we can group the toothpicks in 2 different ways, I just wanted to also show what our arrays could look like to show how we could group these factors differently. So in the top one, here's an array to show 2 groups of 2, 2 rows of 2. And if I wanted to show 3 times 2 times 2, it might look like that. So it's kind of like I'm drawing that same 2 times 2 array, and I'm just drawing it 3 times. And if I were to add up all those dots in the array, I should get a total of 12. In the same way, we could do an array. If we grouped 2 times 3 and decided to solve that part first, we would figure out what 2 rows of 3 would be equal to, and then we could just show 2 times 2 rows of 3, or 2 of those same arrays, and it would be 6 plus 6, again, the same total of 12. Just another visual to show you how to think about grouping the factors in different ways when we're multiplying our 3 factors using associative property. Even though my arrays look different, if I added or counted up all the dots in each of them, I would still have a total of 12. So before I give you an example to try on your own, I wanted to give you a little tip that is also something we need to remember with associative property that can be helpful. And that is that you can also take your 3 factors that you're multiplying, and you can rewrite your equation to group them in a more friendly way. In other words, say you have an equation like, whoops, let's make it an equation, put my equal sign there. 6 times 4 times 2. Maybe when you first look at this equation, you might think, 6 times 4, I don't know that off the top of my head, and I might not feel like that's an easy way to group my factors first. And so what you can also do is you can move your factors around, and you can think about it in a different order. So maybe instead of 6 times 4 times 2, you want to think about 2 times 6 times 4. And maybe you want to just solve 2 times 6 first. So 2 rows of 6, we know that would be 12. And now I can think about a strategy for figuring out 12 times 4. It might be a little bit easier, like maybe doing repeated addition and adding 4 12s together. So the main purpose of showing you this is just so that you know that if the first way the factors are written looks a little bit intimidating or tricky, I can also think about how I can rewrite the equation and move the factors in a different order to be a little bit easier, and so that I can feel a little bit more successful with getting started with that first step. This screen showing my work on the whiteboard is just that you can also, once you've solved the factors in the parentheses, once you've done that step of the equation, you can rewrite your equation. So like for 2 times 2 times 3, I can rewrite 2 times 2 as 4 and then solve for 4 times 3, which would still be 12. And same thing for if I grouped 2 times 3 and solved that first, I could rewrite my equation as 2 times 6, and then that would still equal 12. So now it is your turn, the moment you've been waiting for. I would love it if you could pause the video and go grab a piece of paper, something to write with if you don't already have those things, or a whiteboard and a whiteboard marker, whatever is handy that you can use to work and solve these equations on. You have the equation 5 times 2 times 3. And here on the screen, I've shown 2 different ways you can solve this equation by grouping your factors differently. So please solve it both ways. First, grouping 5 and 2 together and solving 5 times 2. Whatever product you get for that, multiply that by 3. And then down below, solve by first multiplying 2 times 3 and grouping those factors, and then multiplying that product by 5 as your last step. Solve this 2 different ways, and we'll go over the answer in just a moment. Good luck. Now you can check your answer. I haven't written the answer in, but I have started showing ways you could have thought about solving the equation in two different ways. And in the first example, if you multiplied 5 times 2 and did that as your first step, if we had 5 groups of 2 or 2 groups of 5, that would be 10. And if you multiplied 10 times 3 or thought about 3 tens, 10 plus 10 plus 10, that would equal 30. In the second example where we're grouping 2 times 3 together, we would be solving for 5 times 6 because 2 groups of 3 is 6. And underneath that, I just showed how if you did skip counting by 5s, you could have counted 5, 10, 15, 20, 25, 30, and 6 5s, or 5 times 6, would equal 30. So both of those ways, using associative property, we have proven that no matter how we group our factors, the answer to 5 times 2 times 3 should be 30. Check yourself, see how you did. And remember, this is only the first day we've practiced this property and exploring this rule. So don't feel bad if you didn't get it today. You guys will have a chance to keep practicing some more. One last tip for solving an equation like this with 3 factors is you could have also moved your factors around if you wanted to. So I can show that by thinking about maybe if I wanted to instead solve 3 times 5 times 2. And I could have, I'll move this down here. I could have done that 3 5s, 5, 10 is 15. So 5, 10, 15. And then 15 times 2 would be the same as 15 plus 15. And that would still equal 30. So we'd get our same answer again. I just thought I would show you, you could also move your factors around if you wanted to. So last but not least, if you want to get a little more practice, which I recommend because associative property can be tricky and multiplying 3 factors can be tricky. So the more practice we get, the better we are with it. Here are some equations you can try on your own. And I've just written the equations 2 different ways just to show you how you could move the parentheses to group your factors differently and solve for different parts of the equations as your first step. So just remember all those other strategies we've been using, count bys and repeated addition and drawing arrays in equal groups. And make sure that you are working these out on paper or having somebody at home check you so that you can feel successful. Okay, well, that was all for today for associative property, multiplying 3 factors by grouping them in different ways. And next time I see you, we will explore another rule that can help us when we're multiplying. It's called the distributive property, and it's a way to help make a trickier equation a little bit friendlier and easier to solve. So I look forward to seeing you next time. Have a great rest of your day. Take care. Bye.
Hola de nuevo, niñas y niños. Soy yo, la maestra Lorena Vázquez, y hoy continuamos con nuestro aprendizaje de matemáticas de tercer grado. En específico, estamos hablando de la multiplicación y la división y sus propiedades. Ayer aprendimos que no importa el orden de los factores cuando multiplicamos. Así que 2 por 3 te da el mismo resultado que 3 por 2. Qué curioso, ¿verdad? Hoy vamos a aprender cómo podemos continuar manipulando y cambiando los números en el orden en que multiplicamos para poder facilitar los problemas y no batallar tanto. ¿Están listos? Vamos a comenzar. Una vez más, vamos a comenzar nuestro día hoy repasando el trabajo que les encargué de la lección anterior. Entonces, les pedí que practicaran para que puedan aprender a comprender por qué el orden de los factores no importa en la multiplicación. El ejemplo que les dejé para practicar era 2 filas de 6 y 6 filas de 2. Entonces, si realmente el orden de los factores no importa, podremos conseguir el mismo resultado para estas dos operaciones. Muy bien. Entonces, aquí tengo 2 filas de 6 ya. 1, 2 filas y cada una tiene 1, 2, 3, 4, 5, 6 monedas de 1 centavo. Entonces, ya sabemos que las filas son los grupos, así que cuando lo escribamos podemos decir 2 grupos de 6 igual a. Muy bien. ¿Y cuántos son? Contemos de 2 en 2. 2, 4, 6, 8, 10, 12. 2 filas de 6 son 12. Entonces aquí tenemos 12 centavos. Ahora, ¿qué pasa si cambiamos el orden? En vez de 2 filas de 6, que sean 6 filas de 2. Pues vamos a tomar este mismo grupo de 2 filas y les enseñé el truco. Simplemente rotamos la agrupación así y ahora tenemos 1, 2, 3, 4, 5, 6 filas de 2. Entonces, 6 filas de 2, ¿no? 6 filas de 2 son, como usé las mismas monedas, 6 filas de 2 son 12. Así que niños y niñas se pueden dar cuenta fácilmente usando una matriz que el orden de los factores no importa. Si yo cambio los grupos y los muevo, pero no cambio la cantidad de monedas, el resultado, el producto es el mismo. Y en este caso son 12. Bien, espero que les haya salido muy bien y vamos a comenzar con la meta del día de hoy. Estoy aprendiendo el orden de agrupación para multiplicar. Puedo cambiar el orden en que multiplico los números. Ahora, ayer nos especificamos especialmente en 2 factores y cambiarlos. Hoy vamos a explorar eso un poquito más a fondo. La palabra del día de hoy es esta, agrupación. Cuando ustedes me escuchen decir agrupación, ustedes van a decir poner en grupos. Vamos a ver, agrupación. Agrupación. Poner en grupos. Excelente. Agrupar es poner objetos, personas, cosas en grupos. Muy bien, y como siempre, sus materiales, un lápiz y papel, pizarra con marcador, cualquier cosa que les pueda ayudar a resolver los problemas o pueden nada más seguir en la pantalla conmigo. Vamos a ver. Entonces, aquí tenemos algunos problemas. Tenemos 5 grupos de 2, 5 por 2. Tenemos 3 por 2, 3 grupos de 2. 3 por 5, 3 grupos de 5. Hemos visto cómo resolver este tipo de problemas, ¿verdad? Yo sé que 5 grupos de 2, simplemente puedo decir 5 más 5, así que sé que la respuesta es 10. Fácil. 3 grupos de 2, yo sé que aquí puedo hacer 3 grupos de 2, 1, 2, 1, 2, 2 más 2 más 2. Son 6. 3 grupos de a 5, puedo contar de 5 en 5. 5, 10 y 15. La respuesta es 15. Muy bien. Pero ¿qué tal si se topan con un problema como este que está aquí? 5 por 3 por 2. Wow, ahora se ve más complicado, ¿verdad? Pues para resolver este tipo de problemas solo tienen que saber que el orden de agrupación, poner en grupos. No importa. Vamos a explorar un problema para averiguar cómo funciona. A ver, este ejemplo dice, Samuel tiene 5 cajas de lápices. 5 cajas. Cada caja, aquí está, cada caja tiene 3 paquetes de lápices. Cada paquete tiene 2 lápices. ¿Cuántos lápices tiene Samuel? Wow, es un poco complicado, ¿verdad? Entonces, para empezar, yo hice un dibujo porque yo soy una persona que me gusta ver las cosas, visualizarlas. Entonces, no se me hace difícil ver cómo estaban juntos los paquetes y la agrupación, poner en grupos de los lápices. Entonces, aquí está el dibujo. Aquí tengo cada cuadrado es la caja, ¿verdad? Y cada 2 lápices es un paquete. So, aquí tenemos 1, 2, 3 paquetes, como dice el problema, 3 paquetes y en cada caja. Y luego dice que hay 5 cajas. 1, 2, 3, 4, 5. Hay 3 maneras diferentes de que podemos usar la multiplicación para resolver este problema. Vamos a ver la primera. La primera nos dice que podemos multiplicar para hallar el número de paquetes primero, ¿ok? Entonces, híjole, 5 por 3 por 2, no sé qué hacer. Primero vamos a averiguar, yo sé que hay 5 paquetes. ¿Cuántos paquetes de lápices hay en las 5 cajas? Perdón. Entonces, si hay 5 cajas, y 3 paquetes en cada una, primero podemos hacer esta parte de la multiplicación. 5 por 3. 5 por 3, si recuerdan, ya lo habíamos hecho acá arriba. 5 por 3 es lo mismo que 3 por 5. Así que ya sabemos que la respuesta es 15. Fácil. La lección de ayer nos ayudó. 15. Ahora podemos multiplicar 15 por 2. Híjole, pero ¿qué tal si no saben la tabla del 15 o no saben la tabla del 2 hasta llegar a 15 y no sabemos cuánto es 15 por 2? Este método quizás no funcione para ti. Entonces vamos a intentar un método diferente porque recuerden, el chiste de la meta de hoy es cambiar el orden de los números para que la multiplicación se nos haga más fácil, no más difícil. Este método no me gustó, no es muy fácil para mí. Así que vamos a ver la siguiente manera en la que la podemos hacer. A ver, cambio de color. Ok, hicimos aquí 5 paquetes de a 3. 3 paquetes de lápices en 5 cajas. Pero, ¿qué tal si primero averiguamos cuántos lápices hay en cada caja? Sabemos que hay 3 paquetes y sabemos que hay 2 lápices en cada paquete, ¿verdad? Entonces, ¿por qué no hacemos esta parte primero? 3 por 2. Recuerden, 3 grupos de a 2. 2, 2, 2. Son 6. Ahora me queda 5 por 6 igual a. Ya no tengo un número de doble dígitos como el 15. 5 por 6, yo puedo contar por 5 6 veces, ¿verdad? Entonces puedo hacer 5, 10, 15, 20, 25, 30. La respuesta de 5 por 6 es 30. Entonces, quiere decir que hay 6 lápices en cada caja y como hay 5 cajas, el total de lápices es 30. 15 por 2 también, niños y niñas, es 30, porque podemos decir 15 más 15 más es igual a 30. Quizás no lo notamos al principio. Hay una tercera manera que podemos hacer esto, porque recuerden, el orden no importa. Entonces, podemos también multiplicar 5 por 2 primero o 2 por 5. Entonces, dos grupos de 5 son 5 más 5. ¿Cuánto es? 10. Entonces, tendríamos 10 por 3, que es la parte que nos faltó. Y 10 veces, 3 veces 10 viene siendo 30. Niños y niñas, ¿vieron cómo cuando multiplicamos, ustedes pueden usar y multiplicar más fácilmente empezando con las tablas y los datos que ya conocen? Así que siempre cuando vean un problema de varios números que tienen que multiplicar, las paréntesis que dibujé así les dice la agrupación. Agrupación. Poner en grupos. ¿Qué es lo que están juntando primero? Y luego multiplican de ahí. Muy bien, vamos a ver para mañana. Para mañana, porque quiero que con sus seres queridos traten de practicar este concepto de manipular los números, ¿verdad? Ya sabemos que tenemos que estarnos practicando las tablas, la tabla del 1, del 2, del 3, del 4, del 5, del 6, 7, 8, 9, hasta el 10, la tabla del 10. Si no me saben contestar cuánto es 7 por 4, quiere decir que necesitan estudiar un poquito más. Pero antes de memorizárselas, hay que comprender cómo funcionan, ¿verdad? Cuántos son los grupos iguales que van a combinar. Así que para mañana, tomen nota. Aquí tenemos un problema que nos va a ayudar a practicar un poquito más. Dice, la mamá de Mario compró dos paquetes, aquí está, de 4 bolígrafos. 4 bolígrafos, aquí está. Su mamá compró 4. Su papá compró 4 paquetes de 2 bolígrafos. Aquí está lo que compró el papá. ¿Cuántos bolígrafos compró cada uno de los padres de Mario? Así que para empezar, voy a decirles, yo voy a hacer una representación visual. Como les dije, para mí es difícil si no lo puedo ver. Entonces, yo sé que aquí está un paquete de 4 que compró la mamá y el problema nos dice que ella compró 2 paquetes. Así que voy a hacer una copia de 2 paquetes. Claro, yo tengo una computadora, ¿verdad? Y estoy haciendo estos dibujos, pero si ustedes no tienen esto, en casa simplemente pueden hacerlo así. Pueden dibujar una cajita y poner los 4 plumas, los bolígrafos. 2, 3 y 4. Y ponemos el segundo. 1, 2, 3 y 4. ¿Vieron qué rápido lo hice? Ahora el papá de Mario compró 4 paquetes. 1, 2, 3, 4. 4 paquetes. ¿Cuántos bolígrafos o plumas compró el papá de Mario? Para mañana quiero que lo resuelvan porque estamos reforzando esa idea que los factores y el orden de los números no importa. Así que la práctica hace el maestro. No olviden, niños y niñas, y tampoco olviden estudiar sus tablas de multiplicación. Ok, muy bien. Hemos llegado al final de nuestra lección. Hoy estábamos aprendiendo sobre el orden de agrupación. Agrupación. Poner en grupos para multiplicar. Y hemos descubierto que podemos cambiar el orden en que multiplicamos los números. Si yo no quiero multiplicar 2 por 8 porque no me sé la tabla del 8 y prefiero hacer 3 por 4 primero o 3 por 2, podemos hacer eso porque recuerda, al final de cuentas estamos combinando todos esos grupos. Así que esa fue nuestra meta de hoy. Y como les he dicho, recuerden, al multiplicar la agrupación, poner en grupos de los números, se hace de la manera que haga más fácil el problema. Si no es fácil lo que están haciendo, si lo están haciendo más difícil, como en nuestro ejemplo que teníamos que multiplicar 15 por 2 y realmente no sabíamos la respuesta, entonces traten una orden diferente. No olviden practicar sus tablas y para mañana vamos a enfocarnos en cómo distribuir los números para multiplicar. ¿Qué significará eso? Los espero aquí mañana para aprender. Muchas gracias y hasta la próxima. Cuídense.